So that model has finished training, but these are just toy models. I don't necessarily think that I will actually use them for any kind of actual object detection. I'm just trying my best to maybe get a model which can be used for some kind of prediction, but I doubt it. Or training models on these systems, which is like your home system with one GPU and things like this. This is okay, just for trial and error, maybe just for learning something, trying something out. But I don't think any serious training can be done on this. Okay, but just to show you now. It is run for 100 images. I've just done it for 100 images. So 100 image input data set, there's hardly anything that you will get as classes. So if we look at the log file which got generated right now, so this is the one, and it says okay, 999 iterations done and total loss and everything it is publishing. So this is okay, but I want to see this events, what exactly this events is, and the events starts at iteration 19. Okay, that is okay. So at iteration 19 it starts giving you the loss and other things, then it just goes through that. There's a lot of information in this log file. What else can we have a look at? Uh, Now this is very interesting. So it says removed 78 images with no usable annotations, 22 images left. And yesterday only I was looking at the code, and there in the code I found this, that where this thing comes from. It comes from build.py line 69. Okay, it says removed so many images with no. So what exactly does this mean? uh, I have given it 100 images. 100 images I have given it as the training set. So it says that 78 images with no usable annotation. So are my annotations wrong? Have I not converted the data set properly into the format? No, that is not the case. Those 78 images that it is saying that it does not have usable annotations, those images don't have these classes: the person, the motorcycle, the bicycle, and the car. The only four classes I've chosen, right? They don't have these classes. So now what has happened is only 22 images it could find which has got these classes. So firstly, you need to be cognizant about the ground truth. So let's say you have some kind of limited requirement to train for say only these four classes. Then you will have to actually go and search through your entire data set. In this case, if you're taking train Coco, then train Coco has got more images, but I'm just doing validation Coco. I've not even downloaded train Coco till now. I'm just playing around with the validation set. So within the validation set also, I need to go and look for the ground truth and make sure that whatever images I'm picking up, actually those ground truth bounding boxes are there for the classes that I want to train. Otherwise, what has happened is it is saying it within this 22 images also, it has not found any person ground truth labels. So how come I picked up this 100? I really don't know, because the earlier ones which I picked up, I could see uh, the person, this thing in that. These were the ones. So maybe okay, this one doesn't have a person. This one has a person. Uh, this doesn't. This has two persons. Doesn't. Again, one person, just the foot. But if you to pick up something of this sort, let's say I pick up something of this type, person 89%, just the foot is shown, and I pick up maybe 20-30 images of this type. What model am I training? I'm training a useless model then. This is okay. Lady and child, this is okay. This also is not useful. A guy on a cycle, that also one of those, I don't know, circus cycles or whatever that guy is. Again, useless. So to train an actual model and get some kind of outputs out of that, there'll be a lot of other efforts required. Yeah, just this random stuff that I'm doing right now is just to be able to show as to how this entire thing works, and maybe look into the code more in depth and try and understand. That's all. So okay, now to look at this further, what else does this give us? Mm, so this I don't know, this is new to me. Skip loading parameters. Why is it skipping the loading of parameters? Okay, yeah, okay, this is okay. This is understood. This has got to do this is a warning, and this has got to do with something which I am aware of, but right now I will not really bother. Okay, so this is my model summary. So this is my model summary, and if you look at this, uh, so this is the proposal generator. What is the proposal? Basically, proposal is what you are proposing as the uh, uh, predicted bounding box for a particular object, right? So this proposals is what is being compared with your ground truth bounding boxes, and that entire thing happens here. If you look at the code of this ROI head, uh, select foreground proposals, right? So proposal list instances, list of n instances, where n is the number of images in the batch. Okay. Um, so all of this is here. If somebody wants to go ahead and read this, it is quite detailed. Proposals, okay. Select proposals with visible key points. This is for key point, maybe not for object detection. Yeah, but at least this one is for our this thing. This arrowheads is definitely for object detection for our what model we've trained right now. And of interest to me is this batch size per image, because this batch size per image I've been playing around with. One second. Batch size per image. Yeah. Here. So batch size per image, I've reduced to 128. Earlier, where I have access to 4 GPU, on that machine I've been running at 256. And on that machine I've been running over here this images per batch as 4. Here I've been running iterations to the tune of 9,000, 10,000, those many iterations. Learning rate I have not changed. Learning rate I am keeping the same for this experiment and for larger this thing. So this obviously when I changed this one, and I brought this down to 1000, and I brought this down to 128. I stopped getting the CUDA error. Otherwise I was getting the CUDA errors, these ones. Yeah. So I stopped getting the CUDA error when I basically reduce these numbers over here. And all of this I have kind of I have not documented really right now, but I've just put it over here in the initial setup MD. I just put all of this here. Later on I'll if required, I'll create a errors MD or something, or issues MD or something. So I'm just putting over here randomly saying that this is what it is. Okay, now to the code, and there's some substantial things that I put in over here. One is the launch method. So the launch is over here. So in their plain train net.py, they use the launch, and the launch is defined over here in quite detail within the Detectron engine launch this thing. So most of the code for launch I picked up from their official implementation, and just basically put it here. So what happens is this. It really works best when this number is more than 1. So right now the number is just 1. You just have access to 1 GPU, and you're going ahead and running it on that. But if this is 2 GPUs or 4 GPUs, then definitely the situation is a good situation. So num machines is the actual machine that it is running on. You can have num machine 1, you can have num GPU 4, because if on that one server or on one that system you have 4 GPUs, so that is okay. Machine rank, if there is only one machine, then machine rank will be 0. uh, distrib- uh, uh, Distributed training URL, if I'm not wrong, and the args for that. So let this remain on auto, unless of course you are doing distributed training on multiple machines. Then you need to change this, and there are recommended values for that. You find that, I think, within this itself. Okay. So this is the output that I'm actually not using it anywhere. I don't think so. I'm using it. Not using it now. I was using it earlier. Threshold value, that is the 70% threshold for, again, this was for visualization, but 70% I'm also keeping 70% as the IOU threshold. So anything which is below 70% and is identified as that particular object. So anything below 70%. Below 70% uh, and is identified as a true positive, uh, that is actually a false positive. Okay, so I should not say identified as a true positive. I should actually say identified as a category of the um, objects we are training for, or category of the objects that we are inferencing for. So that is actually a false positive. Yeah. So that's the reason we are using this threshold. So this is, again, I was this I'm supposed to do. This is something else. We'll talk about it later. So this we've already seen. We've seen the my input annotations. This thing URL, sorry, CSV file. Along with my input annotations and the local path for those images. So this is what is required. Without this, we can't register the dataset, right? So this one is required for registering the dataset. But now, when we actually run this train data custom, the registration of dataset and everything, all those methods, firstly they cannot be class methods, because if they are class methods, you'll require that default argument self to be there, and they will fail. Detectron requires all the methods which are basically over here, the launch main function. They call this the launch main function. Whatever is within the launch main function, the registration methods and everything, needs to be having no arguments. So I put over here args none, no args or input params, and okay, so yeah, this also for parallel GPU compute, we will need to register datasets every GPU instance. This I'm not very sure if I am doing this the right way, but when I have run it on 4 GPUs, the data parallelization is happening through the launch itself. We are not doing any data loader or specific data loading in a parallel manner. So because of that, I've gone ahead and implemented it this way. I have not really gone back and checked the official implementation, but this one worked for me. This worked pretty much okay. Okay, then this is default trainer. We are not using this. We are using something else. So distributed data parallel. This is definitely required if you are using the launch and you are again using more than one GPU. Then this is required. But for now, I've commented this out. Then the dataset catalog. So this is where the catalog, the dataset gets registered. So register. So I call it the Coco eval data underscore 2, and we have something called the Coco eval data underscore 1. So there are two different datasets that we are registering, one for train and one for evaluation separate. Whereas the method that we are using to register these datasets is the same. So what basically Detectron documentation says about this method is that every time this method has to return the exact same dataset in the exact same format for the dataset to be considered to be registered. Otherwise, you've gone and registered, and it gives the return structure is not similar, or the return, there is some change that is happening every time you're registering. That registration will fail. It will not be considered as a registration. So yeah, so that we need to be careful about. And okay, so let's have a look at this, and we'll or let's go through this train first, and then we'll come back to this. So what will you get out of this? Here is where you registered. Here is where you've created that dataset. So internally, that dataset got passed into your dataset catalog, and then out of your catalog, when you want to get it, so you use this get method and you get this dataset. So what it returns to you is a COCO standard data dictionary, which is registered. So that's the reason I gave it such a long name to this variable, so that you can understand what's happening. So in the COCO standard data dictionary format, you get a registered dataset which is returned, and then the length of that dataset. So in my case, because right now I'm running a very small dummy this thing, I'm doing it for 100 images only. And if I look at this in my log file, I will see that it will print 100. It's printed 100. Yeah, so this is where that comes. And so then this is my COCO classes. So this is the classes that I picked up out of that almost how many are there? Uh, 1 second, I have it here somewhere. All the classes were listed out by somebody on GitHub. I just picked it up from there and I put it here somewhere. But that's okay. We can have a look at that later on. So it's almost 80 if I remember, 79 or 80 which are there. The background is 0, and the person starts with 1 and goes on. So I picked up the first four actually: bicycle, car, and motorcycle. So this is 1, 2, 3, and 4. But once this is done, and then I start to set the thing classes over here as the COCO classes, and after I have done the data set registration, this actually errors out. So it forces me to give the person the index 0, and then 0, 1, 2, 3 over here, and then the num classes I can provide as 4. Otherwise it fails. I don't know why. So I tried to look into their issues and everything and try and figure this out. I couldn't, but I have done the same thing earlier. So in my in my work, this thing. So over there, if I'm training for 4 classes, I start off with the initial class as 0. So I've done the same thing, but I don't know. Maybe for COCO, it should have been different because they have a background or 0 as background. I don't know. Anyway, so so then from this metadata catalog, what I want to do is I want to set the thing classes as these COCO classes. If you don't do this, you miss this step. Things don't work out well. The metadata doesn't work out. Gives you errors. So once this is done, I want to then check again, validate whether that thing classes got done properly or not. And then if I look into my log file, this is getting printed. It is saying length classes is 4, and name of the COCO classes I'm getting out of that configuration. Right, so that's gone into the configuration. Then the COCO eval metadata itself, I want to print out, and I'm saying, so I put a comment over there saying that the thing classes have now got set. So if you look at this, this is what it is, and this is the line. So thing classes is set, and I'm getting the name of the data set. So this is good enough for me for now. I've seen people putting in a lot of other metadata, and they recommend that if you require it, you go and put on a lot of other information over here. But I didn't really use this, so I think I'm okay with this much. Okay. Then Okay, so this is the default argument parser, and I'm getting something called the args default initialized args basically. Yeah, and within that, so I'm just printing out what is the type and all that. So it's argparse namespace. So that is okay. That's the argparse this thing, and how to relate to this? What exactly is this? This is part of the launch. This is part of the launch. So one second, let me put a placeholder here. I say foobar, so I'll just come back to the foobar. So this args over here, right? Even though nothing is defined, and one second, did I? Okay. In my earlier code, I have actually, put those args over here in the main also and printed them, but it's not required. So it's ultimately this default args which are there. And within this, what they want you to do is whether you want to resume false, true, the training part of it, whether you want to do it for evaluation only, num GPU. So this num GPUs is very important for me when I'm doing multiple GPU training. Over here, this num GPUs, I print it. First, I see one, and in the second one, I again see one because I've actually okay. I've actually not changed that number because I have access to only one GPU. But if I were to make this 4 over here, if I were to change this to 4, and then I were to run my code, this my args would get updated. And then over here, in the second printout over here, I would see 4 in place of 1. But for now, I see 1. So that is okay. It doesn't matter. Very irritating to be training on one GPU when you've been doing this on 4 or more, but yeah, whatever. So yeah, the machine rank and everything, this I've already kind of gone through. Okay, so now this args, I'm just renaming the because in setup in their official code they call it args, so I just wanted to keep it as args. And this is again exactly same code out of their official documentation for launch. Um, Setup is doing basically one thing. It is just making sure that it is putting whatever you want to add into your additional config. Right. So earlier, like I said, that you pick up a config from their default trained models from their model zoo. So through config and model zoo and everything, you set up the initial stuff. Once that initial stuff is set up, and over here I've given this reference to their modelzoo.md. Things are explained in quite detail over there. One second. Yeah, okay. So I'm looking at the original file, but I also created one copy of this and I've committed it to Git so that in case anybody, one second. Where did that go? Yeah. So that in case anybody wants to have a look at it, you can. And then I'll be putting few more things over here, like the RCNN will come here and few other things will come here because okay. So in their modelzoo.md, they very clearly mentioned that what is this 3x and what is this 1x. So 37 Coco epochs this model has been trained for, and the other one has been trained for 12 Coco epochs. And they say, okay, even though this has been given here, this one is not to be used for anything substantial. This is just for so anything which is 1x is not to be used for anything substantial, just for maybe a comparison study or something, whatever. Well, these are not models which are trained for a long duration, for a large number of epochs. Okay. Coming back to yeah. So I think I should now and set up and then do train. Build setup, build model, and do train. Okay, and that's about it. So there are other few things which this is part of my to-do list for this, and how to understand the journalized RCNN model, and Detectron modeling meta architecture, and RCNN.py. Okay, so this again, we could have a look right now, maybe, or maybe later on. I will have to go into detail with some comments and everything over there. Um, so okay, so build model is from here, build.py, and this all we need to get into later on. Okay, so now that we've seen the train data custom, the first thing that we want to go and have a look at is the get standard data dict. So this I have gone through earlier also. In the last video I was just talking about this. The only thing I've changed over here is I have put the Coco classes dictionary, and read file rows. This is basically 100. If so, I will go ahead and pick up 100 images by keeping this here out of this particular file. And again, I have gone through this code earlier, so I will not spend much time. The only change I've done is over here. So dict Coco classes, we are looking into the values. Whatever is that value over there, if it aligns with our ground truth label, which is ground truth label is coming from that file, and this these values are what we have kind of selected as the four classes that we want to train. Whenever these two align, you go ahead and give it as the category ID. So that category ID goes in here in the annotations. As this we've already gone through. Some unindents have happened over here. That's all. Just because of this if over here. That's all. This code is same. So okay. No, this is not the one. So like I said, I'm using this in two places. Okay, this is the one we were talking about, and then all of this is okay. Go to setup. Setup is basically just the configuration. So that custom dataset name is this. The args is a dict, and so it will create configs and perform basic setup. Code taken mostly as is from Detectron documentation. So okay, so get config, and then you print that config. Okay, so you can see a difference in this config. What was earlier and what all you have added. That is the whole point of it. So if you look at this, I will just to show you, I will just take this on top and I'll put it here, and then we can compare proposal files train. If I look at this, so here everything is blank. Here in the train you get Coco eval data 2, right? So which means this got added to our config. Our output dir got added to our config. Yeah. So going to build model. Okay, so this is, there was one which we were printing earlier. One config was that. This is the second config that we are printing. So that initial config, this config has got appended to for build model. Okay, so whatever we have done till here, all of this gets added to that config. And some of these things I was just talking about earlier, that without changing these values, like if I were to run this on a machine, maybe even with a single GPU, but more memory available on that GPU, then you can run with four images per batch. Learning rate you need not change. Iterations you can have over here also. If I want right now, I can run it for 4,000 iterations, or even more. That is okay. Iteration doesn't really matter as far as the GPU memory is concerned. The batch size per image, definitely this you will have to change. And this batch size per image I also showed you earlier in the ROI heads, right? So in this batch size per image. Okay, so if you really want to understand what is happening there, so it says the number of proposals to sample for training. Okay, but this is memory heavy. So if you have less memory, then you might want to optimize this. So like that's what's been done over here. We've come down to 128. Otherwise, 256 is ideal. 256 is good. And then this 256 into this, multiplied with this number, images per batch, gets printed out as the. One second, let me see if this gets printed out somewhere. I think not now. Earlier there was something. Yeah, earlier there was something. Okay, I'll come back to this. I put a to do here. I'll come. Oh, caps lock. Yeah, so I'll come back to this. There's a calculated number, so there's a calculated value that gets created. So you are aware as to how your this entire batch this thing is getting calculated and everything. Okay. Okay, so this is model weights. This we've already discussed. We have taken this particular this thing, as the backbone for transfer learning. Transfer learning is what we are doing, obviously. So yeah, so all this is this I've already discussed. This is that 70% that I was talking about, score thresh test, right? So anything below this 70% will be a false positive. This is my output there. So okay, that's all. So you can create the config, you freeze it, and then it goes into default setup. This default setup is again, so this is one comment on the original repo. Default setup I can't get into right now, so even I don't remember. I think I've gone through it earlier, but I don't remember right now. Okay, so this is done. Setup is done, and then what else? Okay, then build model. Build model again. For now, I think I'll have to skip. I'll have to come back to this. The do train we can get into. But again, most of this is very, very. So this is where you get to see very, very standard PyTorch code. So if you have never seen Detectron earlier and you've been working on PyTorch, this will be very familiar to you, right? And in place of this do train, what people are also doing is the default trainer. The default trainer is not what I've done. I've done this. Why? Because I thought maybe I'll get into some of this code and try and understand it further, and maybe change a few things here, which I have not done till now. So I've just picked it up from their repo. I've just put it here, and it is just running. And it's doing an excellent job. So this entire code, again, I will have to specifically maybe take time out to explain. Right now, I can't do that. I have not revised this. Okay. Yeah. So, but this is where you can find out that the training has started. The actual training has started. That the model has been put into the train mode, and actual training starts from here. So whatever is happening before this is let's say preparation for training. Yeah. And what is this saying? Like I said earlier, out of 100 he has picked up only 22, and then he's serializing these 22 elements to byte tensors and concatenating them all. So this entire thing comes to only this much memory. So there's hardly any memory usage for such a small data set. That's why things are running. Otherwise, this will fail. This goes up to almost 200 MB, 300 MB for a larger data set of maybe 800 to 1000 images. That is what I observed earlier. So yeah, that is okay. And then length of data loader, because if you put the batch size and everything down to 1. So you're just getting one image in that data loader, right? This one, this data loader over here, you're just getting one image. Otherwise, over here you should get at least 8 to 10 images. Then this thing runs okay. Then you know that things are running in a commercial environment, in a proper environment, and you're not just playing around with things. Yeah. So that's it. I think we've gone through the entire thing, and this code is already on GitHub. Uh, I probably want to do a few more things and maybe train a decent model before I get into inference or evaluation or any kind of testing. Yeah, so that's the plan.